Okay, this is Math CA, Term 2, Week, I think 11. But anyway, we have a bunch of new things to cover, so I'm gonna go over them one by one. Okay, the first thing here is ln. Okay, ln x. Ln x I touched on last week. It's basically log, but with base e. You guys know log is log base answer power, right? You remember this? Ln is what we call the natural log. Okay, it's basically log, but the base is e. E is a number like pi. It's 2.7 something 18, I think. It's on your calculator if you want to put it. 2.718, yeah. Okay, this is ln x. It can be a function. If you have a function f of x is equal to ln x, obviously it's going to have a graph. We have some restrictions on ln x and log x. Basically, the number under the log and the number under ln, it has to be greater than 0. Okay, it can't be negative and it can't be 0. Okay, so you can never see something like ln negative 2. So for that reason, if you want to graph ln x, the domain of ln x will be from 0 until positive infinity. In other words, x is greater than 0. Okay, the range of ln x is all real numbers from negative infinity to positive infinity. Okay, you need to know these two. Since the domain is from 0 to positive infinity, what does that mean? That means x equals 0 is a vertical asymptote. Why? Because, I mean, look at the graph. You can't go past 0, so obviously x equals 0 is your vertical asymptote. Please don't say y equals 0 is your horizontal asymptote. When you're talking about domain, you're speaking about your x values. So that's why you say x equals 0 is your vertical asymptote. Your graph cannot go past 0. What else do we know? When looking at graphs, you should always look at your x-intercept and your y-intercept. Okay, do we have a y-intercept in this case? Since x equals 0 is a vertical asymptote, just so you guys understand, what is x equals 0? Isn't x equals 0 the y-axis? Yes. So if your y-axis is an asymptote, how will you have a y-intercept? Will there be any point on the y-axis to be your y-intercept? No. So no y-intercept. How about your x-intercept? What point will the graph cut the x-axis? If you don't already know how to find the x-intercept, you basically set your equation to 0, because you guys know when you cut the x-axis, your y value is 0, right? So you just set your equation to 0. When is ln x equal to 0? Ln x equals 0. When, remember I told you guys log base answer equals power. Whenever you're setting it to 0, whenever you have log base answer equals 0, that means your power is 0. And whenever you have anything raised to the power of 0, what's your answer? 1. So basically, anytime you see ln x equals ln x equals 0 or log x is equal to 0, it will always mean that x is equal to 1. Okay? This was a rule I gave you guys last week. Remember I told you ln 1 is equal to 0. So basically, right now what I'm telling you is, when is ln x equal to 0? So for what value of x does ln be equal to 0? When it's 1. It's a rule, okay? Take it as a rule. Ln 1 is equal to 0. So basically, if I switched it and I put for you x, ln of what is equal to 0? Oh my god, it's 1. Okay, so ln x equals 0. Therefore, x is equal to 1. So your x-intercept is 1, 0. طيب. You need to know, does the graph increase or decrease? No, see, as it approaches infinity, whatever, Now, this isn't required here, but I have to explain it, maybe because it's صادفت for this question. If they change up the numbers, it will make sense. But you need to know it, okay? Always when graphing, remember we look at the derivative to know if the function is increasing or decreasing, right? Y prime. Y prime is the derivative. If the derivative is positive, yani the graph is increasing. If the derivative is negative, then the graph is decreasing. Ln x. What's the derivative of ln x? You guys remember from last week, the derivative of ln x or ln u is u prime over u, right? Here we just have x. The derivative of x is 1, so 1 over x. Okay, so y prime is 1 over x. طيب, now what do we know about x? It's always positive. So that means 1 is positive, right? Since x we know is always greater than 0, that means it's also positive. So that means our derivative y prime is greater than 0. Teachers explain it like this. They do it like this. X, y prime, y. Okay? Our x starts from 0 until positive infinity. صح? Yeah, 0 to positive infinity. Plug in any value between 0 and positive infinity. Say 1. 1 over 1 will be positive. So that means your function is increasing. Many teachers, they draw this table. Okay. What teachers do after this is they put a number here and a number here. Basically, these numbers here are just going to be your numbers in the range. Okay? We start at how much? Negative infinity. And we end where at? Positive infinity. So that means your function, this table gives you everything about the function. As x approaches 0, the function y approaches, or f of x approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. That's it. Okay, this is what we call table of sign. So let's say we were to graph this. I'll just graph this really quickly. Using what we just concluded, x equals 0 will be an asymptote. So we're just going to put it dotted like this. Okay, we know that we have a point at 1, 0. Okay, and we know that as x approaches 0, it's at negative infinity, right? As x approaches 0, it's at negative infinity, and it increases, the finite increases to positive infinity. So it just goes like, sorry, excuse me. Let me go a bit slower. Okay, it continues like this. Okay, this is the graph of ln x. Type. What do we have here? Ln 10 plus 5x. Okay. So there's a few ways you can solve this question. One way some people might solve is using transformations. The first thing they did is multiply x by 5. So that means your graph is all being divided by 5. You're going to be like, oh, Wali, isn't x being multiplied by... Okay, yeah. But no, the graph will look like it will be shrunken, if you know what I mean. And then they do 10 divided by 5 and they get 2. And since it's adding 10, they say, oh, khalas, you move 2 units to the left, so x equals -2 is a vertical asymptote. You can use that, but like, if you don't know how to work with transformations, you're going to be very confused. There's a way easier way, okay? Forget what I said. You want to select all that apply. Let's take a look here. Ln 10 plus 5x. Now, what did we work with? We worked with ln x. We said that whatever is under the ln has to be greater than 0. Here, what do I have under it? 10 plus 5x. Okay? It has to be greater than 0. Type, what does that mean? Well, remember, by the way, please note for ln, there's never a horizontal asymptote. Huh? There's no horizontal asymptote for ln. Unless it's like ln x over x squared or something like this. But you're never going to see anything like that. For a ln function, ما في horizontal. Okay, so always just cross that out. So you need to know if the vertical asymptote is correct, okay? You need to look for the vertical asymptote. And how did I figure out x equals 0 is my vertical asymptote here? By looking at the domain. Okay, you need to take a look at your domain. Okay, to find your domain, like I told you, we know that the domain of ln x is greater than 0. So whatever is under the ln has to be greater than 0. طيب يلا, solve. Take this to the other side. You're going to get 5x greater than -10. Divide by 5. You're going to get x is greater than -2. Okay? Please, 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 please don't say, oh, -10 you divide by 5 and you flip the sign. No, no, no. You only flip the sign when you're dividing by a negative number. Here I'm dividing by +5. So I'm not going to switch it to less than -2. Okay? So x greater than -2. So what does that mean my domain is? That means my domain is -2, positive infinity. So what does that mean? My vertical asymptote is -2. Okay, so also you don't have to say all this. Just solve for x and you'll see what your asymptote is. Okay, perfect. You got your asymptote. We need to now see the behavior. There's a few ways you can do this. If you want, you can do table of sign, find the derivative and whatever. So I feel like this is gonna take too long. Okay, even though that's the correct way to do it. Okay, you know, I'm gonna do it like that. Okay, find your table of sign just so you can understand, and then I'll tell you a nice, easier way to do it. Okay, y prime, find your derivative, always. Okay, for the behavior, figure out your derivative. Y prime is what? U prime over u. right? For ln, it's u prime over u, so it's going to be 5 over 10 plus 5x. You can actually factor out 5, and you're going to get 2 plus x and cancel up and down, so you're going to get 1 over 2 plus x. Okay. Now we know, now you have your derivative, right? You write your table of sign, x, y prime, and y. What's our domain? From -2 till infinity. Type, try any point between -2 and infinity, you're going to get that y prime is positive. Try it. مثلا -1, you're going to get a positive value for y prime. So what does that mean? Your function is increasing. From where to where? From your range. Your range for ln is always -infinity, positive infinity. So we go from -infinity till positive infinity. So what does this tell me about my behavior? As x approaches -2, y will approach -infinity. Here, what do they say? Y is approaching 0. Wrong. As x approaches positive infinity, y is approaching what? Positive infinity. So that's correct. As x approaches -infinity, y approaches -infinity. أصلا, can x approach -infinity here? Is -infinity part of my domain? No. So that's wrong. Okay? Just remember the properties of ln that I said here. Okay? The range is -infinity plus infinity. Okay? Always. Type. Is there an easier way to figure out the behavior? Yes, there is. You know, this took me maybe one step, but I don't know, maybe some people are not satisfied. X equals -2 is the vertical asymptote. Knowing that this is a vertical asymptote, y should approach -infinity. Always at a vertical, any asymptote, you're either at -infinity or positive infinity. But now we know ln x, it's increasing. At the asymptote, you start low and you continue to increase after it. Okay? So that's why this one here is wrong. The first one, as x approaches positive infinity, for ln x, خلاص, memorize it if you want. For ln x, unless they say negative ln x, huh? Unless they say negative ln x. But for any ln x, as x approaches infinity, y approaches also positive infinity. Okay? And as x approaches your vertical asymptote, y approaches negative infinity. Okay? If you want, you can take this as a rule. Type. Question 2. The rest are, they don't need that much solving. Okay. E to the x. Okay, I'm gonna come and go over e to the x. E to the x. What do we know about e to the x and its relationship with ln x? We know that ln x is just log base e, right? BAP. Right? We know that ln x is just log with base e, right? So basically, in other words, ln x and e to the power of x are inverses of each other, right? Like, look here, ln x. So log base e to the power. You see this, yeah? So this is the same as this. Huh? These two are inverses of each other. Okay, they're the opposite of each other. This is being raised to the power. This is undoing the power. Okay. Type. When we have inverse functions in math, what do we know about inverse functions? Let's take a look at ln x. What's its domain? Its domain is x greater than 0. So from 0 till positive infinity. Type. الرينج تبعتها we said ln is always from negative infinity till positive infinity. Type. We found our domain and range. Okay, we said that there's a vertical asymptote at x equals 0. Type. E to the power of x is what? It's its inverse, right? E to the power of x is just, you could say ln x inverse or something. I don't know. Whatever. E to the power of x is the inverse. So what does that mean when they're the inverse? Remember when we're doing sine and cosine, when we worked with the inverse, didn't we swap the domain and the range? We did. So that's exactly what I'm going to do now. For e to the x, the domain will be the range of ln x. Oh no, let me not take that. I'm going to take this. So the domain of e to the x will be the range of ln x, and the range of e to the x will take the domain of ln x. Like this. Okay? If you had a vertical asymptote at x equals 0, what does that mean e to the x will have? Do you think it's going to be vertical? No. It's going to be a what? A horizontal asymptote at what? Y equals 0. So you can see, if you know ln x, e to the power of x will be very easy. So these are the properties of e to the power of x. If you want to see how the graph looks, it looks like this. It also, by the way, has y-intercept at 0, 1. Okay, know this. If you plug in x as 0, you're going to get e to the power of 0, and anything greater to the power of 0 is 1. And I'm recording, so yeah, okay. Type. So it's going to look like this, the graph. So over here at 0, 1, it has an asymptote at y equals 0. So it looks like this. Okay, this is what e to the power of x looks like. You're going to need this for other questions. The derivative of e to the power of x is just e to the power of x. Okay, this is one of the most famous derivatives in math. Okay, because e to the power of x doesn't change, it's just e to the power of x. Okay, because the rate of change, each point, is just e to the power of x. Okay, the proof for this is not for your level, so I won't be proving it. No, the other ones I proved them before. But anyways, this one, just memorize it. E to the power of x is equal to e to the power of x. Please be careful. E to the power of x, not a to the power of x. Okay, a to the power of x is another case. Okay, so the derivative of e to the power of x is e to the power of x. If you had e to the power of u, what is it? It's e to the power of u, but whenever we have a u, what do we always do? We multiply by u prime, right? Okay. So y prime of e to the power. Okay. Type. Why is this function increasing? If you want to know why, what's the derivative of e to the power of x? E to the power of x. What's our domain? It's gonna be what's our domain? Negative infinity, positive infinity. Try مثلا e to the power of negative 100, you're gonna get a positive number. Try e to the power of 50, you're gonna get a positive number. You're gonna keep on getting a positive number, so that means your derivative is always increasing. Yeah, derivative is always positive, so your function is always increasing. Anyways, let's take a look. 12 plus e to the power of 4x. Okay. Please, what? Oh, the voice crack. Please, please don't get confused. Do I cut that out? لا, I won't cut that out. I'm too lazy to go back and cut it out. خلاص. E to the power of 4x. Don't get confused. It's the same as e to the power of x, okay? The only thing is just you're multiplying each x value by 4, but that doesn't change anything to do with the domain or the range. But what do we have here? We have a plus 12. At this point in grade 11S, you should know that any function f of x, when you add any number a to it, it's a vertical transformation. If this was f of x, this would be f of x plus a. Right? And say this is a. Okay. So when you see this plus 12, what are we doing to e to the x? We're adding 12 units to it, so we're taking it up by 12. Okay, what do we know about e to the x? We know that its domain is negative infinity, positive infinity, and we know that its range is from 0 till positive infinity. When you're shifting it vertically, are you affecting the domain or are you affecting the range when you're going vertically? Obviously, you're affecting the y values, so you're affecting the range. So what's the new range going to be if you're adding 12? What's 0 plus 12? 12. What's infinity plus 12? It's just infinity, right? So this is your new range. So let's take a look. Its domain is the set of positive real numbers. Is it only positive real numbers? No. Its domain is a set of all real numbers. Yes, from negative infinity to positive infinity. Its range is the set of positive real numbers. Is it from all positive real numbers? E to the x is positive real numbers. Okay. What do I? Yeah. E to the x is the set of positive real numbers. But this is e to the x plus 12. Or you could say e to the power 4x, but it doesn't matter. عادي. But so what matters here is the plus 12. Since you have the plus 12, this is wrong. What's our range? It's 12 positive infinity. It's the range of set of real numbers greater than 12. It's the range of set of real numbers greater than or equal to 12. This is very wrong. Okay? e to the x, the range was 0, infinity. We know that e to the x has a horizontal asymptote at 0, okay? And by the way, this is why I put the brackets as an open parenthesis. If you wanted 0 to be included, you use the square brackets, okay? Anyways, you know you have an asymptote at 0. So when you're shifting it up by 12 units, this asymptote is also going to be carried up, come in with you. So 0 plus 12, so come in, this has an asymptote now at what? Y equals 12 has a horizontal asymptote. In case they asked it, maybe they say it has a horizontal asymptote. Maybe they put for your choice horizontal asymptote at 0, horizontal asymptote at 12. You have to pick 12, okay? Why? Because come in, the horizontal asymptote gets shifted up along with the graph. It's part of the graph, okay? That's why this one is wrong and this one's correct, because you cannot have 12. It's an asymptote, okay? Your graph cannot cross 12. Question 3. Okay, this is great and stuff. I'm not going to take too long on it, but you should know that for any exponential increase or decrease, you start with p0, 1 minus, I don't know, r to the power of x, okay? Or sometimes we call it n, but for the sake of graphs, we're going to call it x, okay? p0 is your initial value, okay? 1 minus r represents your rate, okay? But it has to be as a decimal, not as a percentage, okay? So let's take a look. A function f is defined such that the value of f of x decreases by 5% for each unit increase in x. Okay, you know, I think I should keep it as 1 plus r, okay? Depends on your teacher what she uses, okay? Or he uses. The graph of the function has a y-intercept of 55, which of the following could be the equation of this function. Type. Let's take a look. What's our formula? Initial value, rate as a decimal, Okay, what's the initial value? The initial value is when x equals 0. صح? They said it has a y-intercept of 55. What does that mean? When x equals 0, y is equal to 55. So our initial value is how much? 55. 1 plus r. R is a decrease by 5%, so negative 0.05, right? If you don't know how to convert percentage to decimal, drop out of school, seriously, okay? 1 plus negative 0.05 to the power of x. Simplify this, you're going to get 55, 0.95 to the power of x, okay? This is your answer. By the way, if you're doing SAT, I think you need this. I'm not sure, but I think you need this for SAT. Question 4. This is very easy. This is from last year. The given function models the volume in a balloon t minutes after a hole was poked. What's the volume before it started? Okay, before it started, how much was the time? Time is equal to 0, right? Before it started. Time. Plug that in here. 5 plus 70 e to the power of 0, because negative 0.04 times 0 is just 0. E to the power of 0 is just 1, right? So 5 plus 70, 75. Question 5. The exponential function f is defined that f of 0 is 5, so they gave you the initial value, and the value of x increases 10 times. So they gave you the rate of change is 10 times. It's not a percentage here, it's a 10 times. Okay, they told you 10 times. For this, when we had p 0 times 1 plus r to the power of n, this scala, you're going to replace it by 10. Okay, because that they gave you the rate is 10 times. But when they give you a percentage, you use 1 plus r. Okay. Which of the following equations represents the function f? Okay, it's increasing every time by 10 times. Okay, so p0 is what? 5. Your growth rate is 10. And you put x outside. So easy. Question 6. The given equation estimates the selling price. They gave you this p equals 48 times 0.95 to the power of t. What is 0.95? Like, when you have a decimal, oh my god, when you have a decimal as a rate, that means what do they do? 1 plus r to get this decimal, right? Until you have 1 plus r and 0.95. You kind of have to know what's the 0.95. Mentally you can say, oh, 0.95, and it's decreasing by 5% every year. That's pretty obvious. But for those who don't know, take 1 to the other side, r is equal to negative 0.05. As a percentage, what does that mean? 5%. And since it's negative, that means it's a decrease. Okay, I'm pretty sure if you're doing the SAT, you need to know this stuff. Anyways, so it's a 5% decrease, so it's decreasing by 5%. I don't think it's too hard. Okay, man, this stuff, it's all from last year. The table below shows the lengths of wires an electrician uses to make different numbers of jumpers. Based on the table, describe the relationship. Okay, 4 to 8, that's times 2. 5 to 10, it's times 2. 7 to 15, that's approximately times 2 point, I don't know, 0.5 maybe. I recommend times 2.05. No, approximately, I don't know for sure. And this is times 2.0. This is 2.05 أكيد. طيب. Okay, yeah, أكيد it's going to be approximately linear. Since you're multiplying by 2 almost every time. Since each inch of wire may be used to make 2 jumpers. It's not going to be exponential. Yani you're going 2, 2, 2, 2, 2 every time. It's definitely not going to be exponential. This one, it's correct linear, but they said each wire is used to make 5 jumpers. Okay, no, it's 2 jumpers. Question 8. Okay, type. I told you that the derivative. Yeah, I was saying, I think I cut off. E to the power of x, the derivative, is also e to the power of x. Type, let's say you want to anti-derive. Isn't that integration? Isn't that just reversing it? So that means integral of e to the power of x dx is also going to be equal to e to the power of x plus c. Okay, but let's say you have e to the power of u dx. What do you have to do? You obviously have to multiply by, or no, you have to divide by u prime. Right? E to the power of u over u prime plus c. But I don't think they asked one with u. I don't know, we'll see later. Anyways, know the integral of e to the power of u. But here they put x. Okay, is integral e to the power of x ln? No, ما خاص. This one also ما خاص. Integral of 1 over x is ln x, remember? Integral e to the x is minus 1 over x. No. Integral e to the x is just e to the x plus c. Yes. Question 9. Which of the following is equal to the derivative of 7 to the power of x with respect to x? This is why I told you, please know the difference between a to the power of x and e to the power of x. E to the power of x isn't a letter. This e isn't a letter that changes to مثلا 2 to the power of x, 5 to the power of x. No. E is the number itself. Okay, it's like saying pi to the power of x. Okay, it's a letter. This is Euler's constant, 2.718. Okay, but when we talk about a to the power of x, a is a variable that can be changed. 5 to the power of x, 7 to the power of x, 9 to the power of x, and so on and so forth. Okay, so these two have separate rules. So you need to know that the derivative of a to the x, so when you see a number, that's a to the x. When it's just e to the x, then it's just e to the x. Okay, the derivative of any a to the x is a to the x ln of the a under it. So the derivative of 7 to the power of x is 7 to the power of x ln 7. There you go. If it was a to the u, it's the same exact thing, except what do? You multiply by u prime. Always. Question 10. Oh my god, I don't like this question. Okay, wildlife. Okay, I'm gonna wrap it up. Okay, she's studying eggs. The first one's 85 and the second is 120. How much percent is the second heavier than the first? If you want to calculate how much percent, you can. She calculate the difference. So 120 minus 85. Okay, so you get 35, and you want to calculate how much percent of 85 is 35. So you just divide by 85 times 100, and you get 41%. Okay, there is a formula, by the way, for this. It's when you have an increase or decrease, It's final value minus initial value over initial value. So 120 minus initial value over initial value, and then obviously since it's percent times 100. Okay, that's a formula. But no, you don't have to memorize. That's logic. Okay. Anna observes a colony of 8,000 macaws, which is 4,000 pairs. By the end of the year, 15% will die due to natural causes. At the end of the first year, how many macaws are there? Okay, so each pair raises one chick. So you have 4,000 pairs. فيعني you have 8,000 macaws. Okay. And these 8,000 will lay how many? They will lay 4,000. Why? Because 8,000 macaws is 4,000 pairs, and each pair will get me one. يعني since I have 4,000 pairs, I'm going to get 4,000 chicks. I'm going to get 8,000 originally, plus the 4,000 attached due to the 4,000 pairs. Okay. And then I'm going to get 12,000. But they said 15% at the end die. فيعني بتاخد 0.15 times the answer, and you're going to do 12,000 minus that. Okay, you're gonna get that. Why 12,000? Because I did 8,000 plus 4,000, 12,000. So you can, in other, let me do this in a way where you can properly understand. 8,000 plus 4,000, right? Minus the 15% that died, you get 10,200. Anna predicts the colony will grow as follows. At the start of the year, the colony consists of equal numbers of male and female macaws who form pairs. Each pair raises one chick per year. By the end of the year, 15% of all the birds will die. 1 year old macaws also form pairs and raise chicks based on these assumptions after 5 years. Okay, we need to know, first thing is, they all start with 8,000, okay? And they all have 5 years. So this is the base, and we got that. But what's inside is what matters. What's the growth rate? We know 15% will die, okay? And we know that over here, each pair raises one chick per year. 15% will die. 1 year old macaws also form pairs and raise chicks. Okay, so you need to pay attention to this here. That the 1 year old macaw, you have the pairs that form chicks. Okay, so let's think of it like this. Let's say you have n macaws. Okay, think about it like this. Okay, each pair will form a chick. Okay, so we're gonna think about it like this. You have 2 macaws over here. These 2 will form a third macaw, right? So you have now 3. So if you think about it like this, you had 2, each 2 will get you 3, right? So how much is the growth rate here? It's 1.5. How? 2 times 1.5 is 3. Okay, you're gonna tell me what are you doing? Okay, here's a better way to do it. You know what? Yeah. I think what most people be confused on is the 1.5 part. Okay, like I told you, since each pair is raising one chick per year, you have 2, you're ending up with 3. How much is the growth rate? 3 divided by 2 is what? 1.5. So if you had n macaws, you're gonna end up with 1.5 times n. But what did they say? 15% of the birds are gonna die. What does it mean when you have 15% are dying? So it's a 15% decrease, right? So what we're gonna do, we're gonna do minus 0.15. So 1.5n times the rate, which is 1 minus 0.15, all raised to the power of 5. Okay, so 1.5 times 0.85 to the power of 5, and your initial value is how much? 8,000. Okay, if this comes in the exam, what do? You take your initial value, you throw it in there. Okay, it's already given. All of them have the same initial value. The power is already there. What you need to focus on is here. It's going to be a product of 2, because always it comes copy paste. It's going to be a product of 2. If it's following the same thing, two pairs, and one pair will get you one chick, then it should be 1.5. Maybe they change it to maybe 20%, so it will be 1.5 times 0.8. So it should be 1.5 times something. But if it's a dying, if it's death, so you should do 1 minus whatever value they give you here. Okay. How many questions is this? 21. طيب, Iyad is preparing a tutorial video about building a timber border around the garden. But this is from last week. Okay, I'm gonna go through this a bit quicker. So you have 9 here. Okay, you have this plus this is 3. This plus this is 3. Okay, and then you have this plus this is 9. Okay, so you're gonna get It's how much? 18 plus 6, 24. So that's checks. Good. طيب, here you have, this isn't 9. So you know, this plus this, no, you know, other way around, sorry. This plus this is 9. This plus this is 9. This plus this is 3. This plus this is 3. You get 24. This is 9. This is 9. 3, 3. Again, you get what? 24. This, okay. This here is 9. This here is 9, right? They gave it to you. So 9 plus 9. Hello. This plus this is not 3. Why? Because it's slanted. Whenever you have something slanted in math, it's going to be greater than the straight line. Because if you unbend it and make it straight, it's actually going to be maybe this long. You see? So since it's slanted, it's going to be greater than 3. You could say maybe, I don't know, 3.8. Okay? And since this one here is also slanted, it will also be around 3.8. And therefore, you're going to get something greater than 24. So can he build block D? No, he can't. So it's going to be A, B, C. Question 12. Okay. Here, integral of, this looks scary, but please don't panic, okay? Integral from 0 until 1. 30x e, oh, no. 30x times e to the power of x squared minus 2 dx. Okay, obviously, you have the e. Okay, you can split this up into two integrals, do whatever you want. But I gave you the rule here is eu over u prime plus c. Okay, honestly, I hate using the rule because, especially in cases like these, you can't really work with it. Okay, you can do it like, look, you can rewrite this as 30x eu over 2x du. Okay, from 0 to 1. This works. Okay, this is basically using the rule e to the power of u over u prime. Okay, but instead of taking it out, I kept it inside. Why? Because I want to, you see this x here? It's annoying. I want to cancel it out. Okay, so when I did this eu over u prime, I did eu over u prime, huh? Okay, u prime is 2x. X squared minus 2. What's the derivative of x squared minus 2? Is 2x. So now I can cancel this x with x and 30 with 2. I'm going to get integral 0 to 1, 15 eu du. Now what can I do? 15. What's the integral of eu? 15 I take to the side. What's the integral of any e to the power of u? Just e to the power of u. And my bounds are from 0 till 1. Don't forget to change u back to x squared minus 2. From 0 to 1. In my opinion, this isn't correct, what I just did, okay? I'm just following a stupid rule that the book gives. Also, I don't know if it's in the book, but I saw someone do this, okay? In my opinion, this isn't how you solve, okay? Here's how I feel like you should solve, okay? Whenever you have something that is x to the power of, or when it's different than x, you have to use u substitution. So u is equal to x squared minus 2. So that means du is equal to 2x dx, right? So that means dx, since we want to change it into du, we need to find an expression for dx. It's du over 2x. So therefore, you can write this as integral 0 to 1, 30x e to the power of x squared minus 2 du over 2x. Cancel x with x, 30 with 2 comes 15, which is almost the same thing. But this work... this changes into u, huh? I don't know why. U. Okay, but 15 du. Okay, this is the same thing I did earlier. But what's different is now when you integrate EU, some people are going to see, oh, EU, then I have to use the rule again. No, that's the thing. Some people, after they do the steps I did before, they're like, okay, I'm left with 15. Okay, 15, we take it out. Then what's integral EU? They're going to be like, oh, integral EU is EU over U prime. And then you're going to be stuck in a loop because... you're going to be left with e over u prime and you're going to integrate. Anyways, let me stop here. This is the way I solve. Integral of e to the anything is just e to the u. right? What does this rule mean? It doesn't literally mean if you see e to the power of u, it means it's e to the power of u over u prime. No, it doesn't literally mean that. Okay? Notice how I said e to the power of u and then I have dx. That means يعني something in terms of x. But no, we just call it u. Okay? It doesn't literally mean e to the power of u. When you have e to the power of u du, then عادي, it's fine. Okay? But this is what I meant. That's why I wrote dx after it. So you can understand that this is u in something in terms of x. Like here, this is in terms of x. Anyway, you can get 15 to the power of 15 e to the power of u from 0 to 1. Change the u back to x squared minus 2 from 0 till 1. Do it on your calculator. Oh, you can't do it on your calculator. Oh, they want it like this. Okay, and you have to actually do it manually. Type. Substitute 1, you're going to get 15 e to the power of 1 minus 2. Okay, minus open bracket 15 e to the power of 0 minus 2. Type, let's see. 15 to the e to the power of negative 1 minus 15 e to the power of negative 2. طيب هيدي بتكون شو 15 over e because negative power minus 15 over e squared. If you want it as common denominator فأكيد you have to multiply by e. You can get 15e minus 15 over e squared, and they took it out. Yeah, they took 15 out as a common, so 15 e minus 1 over e squared. Okay, so your answer for A is what? 15. Question 13. Given f of x is 70, 2 to the power of 2x, using approximation, ln 2 is approximately 0.7. What is f prime of 0? If you put this in a calculator, I think some people, they're going to think they're smart to هيك. They're going to do this 2 to the power of 2x. وبياخدوها and they put for 0. You see, you're gonna get this. So if you think you're smart and you go get your calculator and do it, that ain't gonna work, bro. Okay, so you have to remember the rules for differentiation of a to the power of x, right? When you have a constant, what do? You take it to the side. Okay, 2 to the power of 2x. What is this? Is this 2 to the power of x? No, it's 2x. So what do I have to do? I have to use the rule a to the power of u, which is a to the power of u times ln a times u prime. We wrote it somewhere here. Come on. I remember writing it. I didn't write it. I solved the question with it. How didn't I write it? Type. Remember a to the power of x is a to the power of x times ln a. The derivative, huh? Or derivative of a to the power of u. Whenever you have u, yani something in terms of x, it's not just x, what do you have to do? Always you multiply by u prime. This is chain rule, guys. Huh? Just remember, whenever it's not just simply x, you have to multiply by the derivative of it as well. Okay? Anyways, so the derivative of 2 to the power of 2x, what is it? It's 2 to the power of 2x times ln 2 times u prime. What's the derivative of 2x? It's just what? 2. This is the derivative of 2 to the power of 2x. So 70, we took it to the side because it's a constant. Always you take your constant to the side. Okay? 2 to the power of 2x times ln 2 times 2. شو substitute 0 into your derivative. So you're going to do this. 70 into 2 to the power of 0, which is just 1, times ln 2. If you use ln 2 as ln 2, it's going to be wrong. They said use it as approximately 0.7. You're going to get what? 98. Question 14. Given f of... Is my mic working? Okay. It is, huh? Yeah. Given f of x is negative 45 e to the power of negative 3x, what is f prime of 0? Okay, here do we have a to the x or e to the x? We have e to the x. صح? So what do? We use our rule for differentiation for e to the power of x. What's the difference of e to the power of x? It's just e to the power of x. Right? But what do we have here? Do we have e to the power of x or e to the power of u? We have e to the power of u. So derivative of e to the power of u is just e to the power of u times what? U prime. Yalla. Okay. By the way, guys, if you use the rule for differentiating a to the power of x, to differentiate e to the power of x, it will work as well because ln e is just 1. Okay, this works as well. بس انه احنا mathematicians they simplified it. They just said خلاص just e to the power of x. Okay, again the proof for it is very very long. I won't go over it. Anyways, so انت هلا you want to derive e to the power of u. So what do you have to do? You have to multiply by u prime. Okay, so negative 45 we take it to the side because it's a constant. E to the power of negative 3x times, what's the derivative of negative 3x? Negative 3. اضرب, you get 135. Negative 45 times negative 3 is 135. E to the power of minus 3x, so e to the power of negative 3 times 0, which is just 0. So I just put it 0. Okay, so you're gonna get, close the brackets. 135. Okay. Question 15. The solution of the equation. Okay, this is a bit يعني بدها شوية ذكاء. Okay, you need to pay attention here. To solve this equation, the first thing you're gonna do is what? Cross multiply, right? Cross multiply, you're gonna get 7 to the power of x plus 47 is equal to 5 into 7 to the power of x minus 1. Okay, obviously we're gonna have to distribute, so it's gonna be 7 to the power of x plus 47 is equal to, please do not write this, please, okay? It's very, very wrong. You can't, if this has a power and this doesn't have a power, you can't multiply them, okay? So it's gonna stay like this, okay? But you're just gonna distribute it to the negative 1. So let's take all our common factors to each side and work. We're gonna take this here and the minus 5 there. You're gonna get 47, and the minus 5 becomes plus 5, so it's gonna be 52 equals 5 into 7 to the power of x minus 7 to the power of x. طيب, think of this as like a letter. Think of this as like y. 5y minus y, how much is it? 4y, right? So it's gonna be 5. It's gonna be 5 7 to the power of x minus 7 to the power of x is gonna be 4 7 to the power of x, صح? Okay, same way, like 5y minus y will be 4y. Think of 7 to the power of x as y. Okay, if we divide by 4, we're gonna get 7 to the power of x is equal to 13. Okay, and we want an expression for x now. You can easily do this. You can do ln of both sides and take the x down, because you know when you have ln and you have a power, you can take it down. And then you're gonna get x is equal to ln 13 over ln 7. Okay, you can easily take the ln of both sides, take the x down because it's a power, take it as a coefficient and divide by ln 7 on both sides and find x. But they want it in terms of log. Okay, so what do we have here? If you want to write it as a log, remember we have log base answer equals power. Obviously x is going to be the power, right? What's the base in this case? 7. What's the answer? 13. So this is how you get your answer. 7, 13. Remember BAP from last week? That's it. Yeah, nothing too hard. Question 16. Ln e to the power of 20. Okay, guys. Ln and e cancel. Always. You're going to get 26. E and ln cancel. You're going to get 12. Okay, I'm going to make your life very easy. Okay. Question 17. Given y is e to the power of x, what is the value of y prime when x is ln 17? Okay, what's the derivative of e to the power of x? E to the power of x, the derivative is just e to the power of x. Okay, when x is ln 17, so we want to substitute as x how much? Ln 17. So e to the power of ln 17, cancel e with ln, you get 17. Okay, if you want to do it on a calculator, it works as well. Huh? Question 18. Given y is 4 e to the power of x, what's the value of y prime when x is ln 9? Again, 4 e to the power of x, what's the derivative? Constant, take it to the side. Derivative of e to the power of x is just e to the power of x. Type, substitute x as ln 9, so 4e times ln 9. E and ln cancel, so you're going to be left with 4 times 9. Please don't forget the 4, so you get 36. Question 19. Okay, given y is equal to 7... Given y is equal to 7e to the power of x squared plus x plus... no, is that minus? think that's a minus. X squared plus x minus 6. What's the value of y prime when x is equal to 2? Type, let's derive this. 7 is the constant, we take it to the side. E to the power, is this e to the power of x or e to the power of u? E to the power of u. So what's the derivative? Is just e to the power of u times u prime. So e to the power of x squared plus x minus 6 times u prime. What's the derivative of x squared plus x minus 6? Derivative of x squared is 2x. Derivative of x is 1. They want the value of it when x is equal to 2. If I go take your calculator, I'm not going to calculate this. 7e to the power of 2 squared plus 2 minus 6, and this is going to be 0 akid, times 2, x plus 1, so times 2, plus 1, 35. Question 20. Question 20 and 21 have, they're very easy, but you need to lock in for this, okay? And you have to focus just for this small teeny concept. If you remember, for a to the power of x and e to the power of x, the range was 0, positive, infinity. You couldn't get 0 as an answer, right? If you remember. Hatta over here, we talked about it. No, the domain and range of y is equal to the x. You can't, the range, like if there is no 12, you can't have 0. It has to be greater than 0. So you have to use this idea for this here. So x squared times 2 to the power of x minus 16 times 2 to the power of x equals 0. How do you solve this? Obviously, we're going to factor out 2 to the x, and you're going to get x squared minus 16 equals 0. Type in math. What happens when you have an equation like this? That means this equals 0 and this equals 0. So 2 to the power of x equals 0 and x squared minus 16 equals 0. أيوة. طيب 2 to the power of x, can it equal 0? We just said a to the power of x, e to the power of x. The range is always greater than 0. So can you have them equal to 0? No. So you're going to get how many solutions? 2 instead of 3. 2 from the quadratic here, and 1, you were supposed to get 1 from here, but since it's equal to 0, you're not allowed. طيب. So x squared minus 16 equals 0. This is very easy. You get x squared equal to 16. X is equal to plus minus root 16. So you're going to get plus minus 4. صح? So 4 negative 4. But don't be fooled, please, and put some random answer like 1 or something, maybe 0, some people will put. Don't do that. This is the same exact idea. Factor out 3 to the power of x, you're going to get x squared minus 9 equals 0. Okay, that means this equals 0 and this equals 0. This is rejected because, again, a to the x cannot be equal to 0. Take 9 to the other side. X squared is equal to plus minus, x squared is equal to 9. So that means x is equal to plus minus root 9, which is equal to plus minus 3. Thank you so much for watching, and good luck in your CA.